Hey guys, this is the Academic Chemistry Unit 5, Stoichiometry. So we are starting our last unit in chemistry. This is Chapter 11, Section 1, Part 1. It's a little bit of an introduction to before what it talks about in the book. We're going to do some math today, so you might want a calculator. It is addition and subtraction only, so if you want to go for it and do it on your paper with pen and pencil, that's great. But if you want a calculator, go for it. All right, so first thing to review, a chemical reaction. So what is that? A chemical change. It occurs when the atoms in one or more substances rearrange to form different substances. So you see here you've got nitrogen monoxide and ozone, and they crash into each other. And because of that collision, the molecules actually break apart and reform into different combinations. So you're going to have different signs, whether a gas is released, a precipitate is formed, that's that solid that comes from two liquids. If there's a color change, a temperature change that you didn't instigate, those are signs that a chemical change happened. So chemical reactions can be written in two ways. You can either use words, to describe them, or you can use those chemical formulas. So words, for example, would be solid iron metal reacts with oxygen gas to form solid iron 3 oxide. Notice I've used the chemical names for each substance. I've also included what state of matter they're in, whether it's solid, liquid, or gas. So here's how it would look if I use the chemical symbols. Solid iron, so I've got iron, solid iron metal right here, iron, and then I've got this S here. This is the chemical formula for iron. It's an element, reacts with oxygen gas. So reacts with is a plus sign. You have a plus to separate things. Oxygen gas, oxygen is O2 because it is one of the diatomic elements when it's by itself. Then it always takes the form of subscript 2. Remember, those are those Brinkelhoff elements, so oxygen is included. I have this little G because it's a gas. When I say to form, that's going to be shown with this yield sign and solid iron 3 oxide. So I've got the chemical formula for iron 3 oxide and solid state of matter. So for my chemistry students, you might notice one thing, you need to be good at naming. So if you need to review those naming rules, now's a good time. All right. So you'll notice that this equation has two sides. You've got the left hand side and the right hand side. And I've labeled them as red and blue just to distinguish the difference. So on the left hand side, that's your starting material. And it makes sense because it's kind of what, as you read the equation, you read from left to right. So the reactants are the things that are going to react together to make your chemical reaction. So you need reactants to make a reaction. That's the stuff you start with. And that always goes on the left. So it's just like reading English. We start on the left. The things we start with are on the left. Then in blue here, you'll see that we have our products, which is your final material. So what does this actually forming at the end? What substances do you have? Like this only has one substance, iron 3 oxide, but maybe it's making multiple things. So what is it forming in the end? So there's a few symbols. I went over them briefly, but let's make sure you know them all. So if you are separating two or more reactants or products, then you need a plus sign between them. When you separate reactants from products, you have the yield sign. Notice this is not equal to, right? If you have hydrogen and oxygen reacting to form water, hydrogen and oxygen are not equal to water, but they rearrange to make water. An S in parentheses represents solids. An L in parentheses represents liquid. It's often drawn as a lowercase cursive L, which has like a little loop-de-loop, so it doesn't look, not to be confused with the 1. The gaseous state, it's a gas, it's a G. Now this is the funny one. AQ stands for aqueous, which means it's dissolved in water. So like salt water is an aqueous solution of salt and water. Okay, so the law of conservation of matter, all reactions are going to obey the law of conservation of matter or mass. It depends who's talking about it. It could be called both. It means the same thing if you look and see it different ways online. Basically, this says that in any chemical or physical change, matter cannot be created or destroyed. So however many atoms you have to start with, that has to be the number of atoms you end with. You can't just make up atoms. They can't disappear. You can't form them. So for example, if we had this situation and I started with my reactants in here and I had 300.23 grams, even when I have them react and come together, it's still going to be 300.23 grams at the end because mass is conserved or stays the same. So here it is, again, the law of conservation of mass, the sum of all the reactant masses equals the sum of all the product masses. And put in a mathematical equation, it kind of looks like this. The mass of reactant 1 plus the mass of reactant 2. If there was a third one, you'd have the mass of reactant 3. If you only have one, then ignore this mass of reactant 2. So however many of them you have, you add them up. That's what sum means. And then that's going to be equal to the mass of the product 1 plus the mass of the product 2 plus mass of product 3 or mass of product 4. However many products you have, each of them gets added together. So again, if there's only one product, then ignore this. But if there's 3, add another, add another, add another. Okay, so let's do an example with that formula. If 14 grams of nitrogen are reacted with 3 grams of hydrogen to form ammonia, calculate the mass of ammonia. So we're going to take this and put it into a little bit more chemically looking formula. So first thing I want to point out, this word form. So that's saying, okay, the reaction happens. We're going from the reactants to the products. So that's our little arrow there, our yields. Everything mentioned before it are your reactants. Everything after it are your products. So 14 grams of nitrogen, since that's something that's reacting, that has to go on the reactant side. They are reacting with, so that's your plus sign, 2 things. 3 grams of hydrogen, so that's another reactant, because those are the things that are coming together to make your product. And they are forming ammonia. And we don't know the mass of ammonia, so some sort of ammonia. Now I'm going to take this and I'm going to turn it into an algebra equation based on the formula I just gave you for the law of conservation of matter. So 14 plus 3 equals x. Okay, you just add them up. 14 and 3 is 17. So make sure you use some units at the end. 17.0 grams of ammonia is your final answer. Let's do another one. If 16.0 grams of oxygen react with carbon to form 22 grams of carbon dioxide, calculate the mass of carbon used. Okay, so again, to form, there's our yield sign. So I've got 16 grams of oxygen, that's a reactant, because it's reacting with, it's the starting stuff. So reacting with carbon. I don't know how much carbon, so I'm going to throw in some question marks there. Some mass of carbon. And then that's forming 22 grams of carbon dioxide. So there's our products. All right, again, turn it into just a nice, easy algebraic equation. Leave out all the grams, the substance names like carbon or carbon dioxide. Just make it simple. 16 plus x equals 22. Okay, I need to subtract 16 from both sides. 22 minus 16 will be 6. So x is 6.0. But what was x when I go back to the problem? What was it referring to? It was referring to the grams of carbon dioxide. So my answer is 6.0 grams carbon dioxide. Make sure your answer has a number, a unit for how you're measuring, and then the description of what you're measuring. Number, how you're measuring, what you're measuring. 3 things. Okay, so now we're getting into a little bit more fun math, which is the stoichiometry part. And this is just rudimentary stoichiometry. It's a very basic intro to it. We're going to really get our hands wet later. So when chemical reactions happen, they always have a set mass ratio. It always, always, always happens. What do I mean by that? Okay, 102 grams of aluminum oxide will always break down to make 54 grams of aluminum and 48 grams of oxygen. So if you go out into nature and you find some aluminum oxide and you run an electric current through it, if you had 102 grams of aluminum oxide, it definitely has to break up into 54 grams of aluminum and 48 grams of oxygen. So here's our equation. 102 grams of aluminum oxide breaks up to form 54 grams of aluminum, 48 grams of oxygen. Okay, what if I didn't find 102 grams? What if I found double that? What if I found 204 grams? Well, if I double my overall amount I start with, I have to double the overall things I end with. So notice everything got doubled here. My 102 became 204, my 54 became 108, 8. My 48 became 96. Everything on the left and right is still going to be equal. 108 plus 96 is still equal to 204. What if instead of 102, what if I had half of that? Well, if I had half of my starting material, I have to get half of my final material. So notice 102 turns into 51. 54 turns into 27. 48 turns into 24. So here's the equation you want to know. Stoichiometry by mass. Mass of A1. So A is just talking about which substance, and the 1 refers to initially. So my initial mass of some substance, and then my final mass of that substance. So notice I have the same thing on both sides. Then B is just saying another substance in the equation. So my initial mass of some other substance and my final mass, some other substance. Make sure the top has the initial stuff or talking about the same scenario and the bottom is talking about the same scenario. Make sure left and right, left has its own substance, right has its own substance. So be very careful. You're probably going to want to label some stuff when you answer these problems. So if you have 84.7 grams of aluminum oxide, what mass of oxygen can it release? Okay, well, we have 84.7 grams of aluminum oxide, and we also know from before, well, we have 84.7 grams of aluminum oxide. So that's substance A. We have some mass of oxygen, substance B. We also have aluminum oxide down here, so that's substance A as well, which I'm labeling here in blue. And then we have oxygen over here, substance B. So we're going to start with just substance A, the aluminum oxide. I have 102 grams of aluminum oxide on the top. So since I'm putting this on the top, this needs to be on the top on the other side, but we're not there yet. We're dividing it by our other mass of aluminum oxide. See how this equation has mass of substance A and mass of substance A? It has to be the same substance on the top and bottom. So that's why my 102 grams aluminum oxide gets paired with my 84.7 grams aluminum oxide. So same substance top and bottom equals. Notice in the equation, I have my initial on the top, initial. So if I'm saying this is my initial amount, it matches with this amount of oxygen because that's in the same scenario. So 48 grams of oxygen goes on the top, and I don't know, some mass of oxygen goes on the bottom. Before I go any deeper into this equation though, I'm going to make it a lot easier to look at. I don't want to have any grams or any compound names when I'm doing my math. I'm going to bring that back at the end. So I have 102 divided by 84.7 equals 48 over x. Okay, so if you have two fractions set equal, cross multiply. All right, 84.7 times 48 equals, because that's this cross right here. So now I have this cross multiply means you're multiplying them together. So you have 102 times x. I know I want x by itself, so I'm going to divide by 102. Those cancel. If I do it to the right, I have to do it to the left. Divide by 102. Notice I haven't done any math yet. I'm saving all my math to the end, so that way I'm not rounding in the middle of my problem. I'm just going to type into my calculator 84.7 times 48 divided by 102. So this is where you're probably going to want a calculator. You literally just type it in as that, and you'll get 39.8588 equals x. Well, I want it rounded to one decimal place, so I would be cutting off after the 8, so that 588 goes away. 5 was my first number I cut though, and 5 bumps it up, so it's 39.9 grams of oxygen. All right, have fun with your introductory to stoichiometry. Let me know if you have any questions. Otherwise, I'll see you in the next set of notes.